Now coming to the need of object-oriented programming. Now basically there are two types of languages, or two approach for a programmer. Firstly, using the procedural or structural programming languages like C. And on the other hand, we have object-oriented programming systems, for example, C++, Java, and Python. Now, what are the features that object-oriented programming or the languages following the concept of object-oriented programming provides over the procedural programming languages? Now, first point comes of modularity and code reusability. Now, what is modularity? In object-oriented programming, the developers can break the code or break larger problems into smaller and more manageable units called classes. Each class represents a different part of the system, which makes it easier to understand and maintain. Now coming to code reusability. Using inheritance, the concept that is used in object-oriented programming enables classes to share common behavior, reducing code duplication. This allows for the greater efficiency and cleaner code as changes or updates may be made to a base class and automatically that might be reflected to the derived class. Now coming to the second point, that is the data abstraction and encapsulation. Now what is data abstraction? Object-oriented programming hides the internal working of an object and exposes only the necessary parts to the developer so that it can maintain a cleaner code and reduce the chances of unintended interference. Coming to encapsulation, it protects the internal state of the object from unauthorized access by wrapping the data and methods inside a class. This makes it harder for the bugs and unintended interactions to occur, improving the robustness of the program. The last, the third last point is maintainability. Now, what is maintainability? I mean, object-oriented programming allows for easier debugging, testing, and refactoring the code, which is the changes in one part of the system can be made with minimal impact on the other. Coming to scalability and flexibility, object-oriented systems are more scalable. They just need to add a few more functionalities by creating a class or extend the existing ones. Now there are some other important edges of the object-oriented programming over the procedural languages such as modeling real-world problems. OOP closely aligns with how we think about the real-world entities. Real-world objects can be modeled as classes with properties and actions. This makes object-oriented programming particularly useful for complex systems where the relationship and interactions between the different entities need to be modeled. Coming up, improved collaboration. Large teams can work on different parts of the object-based project simultaneously because of its modularity. Each class or module can be developed independently, promoting collaborative development. The next part is security. The encapsulation restricts direct access to objects data, which provides protection and ensures the data security. Efficiency, extensibility are the another major factors that are considered while applying object-oriented programming into real-world problems. Now, the summary for the need for object-oriented programming is it manages complexity in large applications, promote code reusability, saving time and effort, improves security and robustness of the application through encapsulation, models real-world entities and their relationship naturally, enhances collaboration and development teams such as maintenance.